Hello, good evening everyone. This is Patrick Raj. I'm going to explain something about electrochemistry. First of all, when you look at the word electrochemistry, it simply means that we are looking at electricity and chemicals. We can look at how electricity is causing chemicals to react. To react is something like to undergo some oxidation or reduction, or we can have chemicals when they do react, they cause electricity to be produced. And for this case, we begin by how this chemical and these metal here are going to behave, what is going to happen here until you see electricity being recorded on the voltmeter here. And I'll also explain the function of this part here, which is called the salt bridge. Just a piece of paper dipped in some potassium nitrate salt. So I'll go straight to a question, and I'll use this question as my way of explaining this concept here. So when you look at this question, this is a question that is a KCSE question, of course, and it's telling us that there's a metal K and N that were connected to a cell, and the diagram is shown here. And that metal K is this K on this left hand side, and N is this metal that is dipped in the solution of these ions here, and K is a metal dipped in the solution of its ions on the left hand side here. So we are being told that when K ions are dipped, the reduction potential in converting the K ions to K is negative 0.17 volts, and when you want to convert N positive ions to N solid, you will require a voltage of plus 1.1 volts there. So this is very important, because when you say this is a negative potential, you require a negative potential to convert the K ions to K, then it simply means that you actually require this is a more electronegative metal, and this is an electropositive one. So, and you remember that these ones are obtained when you connect this metal rod to a standard electrode potential of you can use hydrogen electrode potential of 0.0, such that when you connect the two, you get a negative potential for K, and you will get a positive potential for V. That is, when you subtract 0 from X, you are likely to get this voltage here. We go to this setup here. This is a setup that is called an electrolytic cell. This is an electrochemical cell. This is a complete cell made up of two half cells. The half cell is just this section here. When you have these K ions dipped, the metal K dipped in the ions of K, it forms a half cell. I remember a half cell is just a metal dipped in a solution of its ion. So there exists this kind of the K ions trying to dissolve in the solution to form K positive ions, and the K positive ions trying to undergo reduction to form K ions. So that kind of shifting in the equilibrium is what is going to generate some electrode potential somewhere. And when you want to determine that electrode potential, you rather connect that half cell to a hydrogen half cell, so that for this case you get negative 0.17, and for this case you get 1.16 voltage. Again, this is also the same. This is a half cell for N metal, that is dipped in N ions. Again, it has a voltage of positive 1.1 volts. This is obtained when you are connected to a standard electrode potential, to a standard electrode, standard half cell, to standard hydrogen half cell. And remember the conditions that we are going to use here. The conditions that we use are that you need to have a pressure of 1 atm and at some standard temperature of 25 degrees Celsius, so that we can get these two values here. Okay, so when you want to understand this full cell, the E cell, the full cell, then you remember that you can use several ways. You can use formulas, you can use different ways of understanding how which side is going to be pulling electrons to which side. And looking at these two metals here, K is put on the right hand side, and remember, when you put anything on the right hand side of an electrochemical cell, then the result is going to undergo an oxidation, and when you put something on the left hand side, it's going to undergo reduction. So for this case here, let me use a pen here. So for this case here, for the reduction potential, you shall be having the N undergoing reduction, and the reduction is a redox. Oxidation is an oil rig. So when you have oxidation, you are going to have the electrons being lost, and then you have a reduction, you are having the gaining of electrons. So according to these, the oxidation on the right hand side is where you are having electrons being lost from this metal here, and when this metal loses electrons, basically we are going to have it is an atom. It is an atom that loses electron, not an ion that loses electron here. So basically what we are saying is that this atom of K atom, my pen is not writing, this atom of K shall be the one that is going to be losing electrons. So we shall be having K atom, which is a solid, losing electrons to form a K positive ion, and these ions are going to dissolve in the solution, and you can get that electron here independently. That electron is going to rise up and going to go through that wire there, and it is going to go through this wire here. I'll tell you why this electron goes this direction. Now this metal N that is on this side here, this metal is where you are having a reduction, and reduction is just the gaining of electrons happening here. So this now for this side here, N cannot gain electron. N is just a conductor. It is going to conduct the electron here, and the electron is under this solution, and now you are having an ion here that requires a charge of 2. Remember, this K had a charge of 2, so it loses 2 electrons here to balance the number of electrons that are being lost and gained here. And for the N then will be N2 plus, gaining all 2 electrons that are lost by K, and in the end you're going to form atoms of N, and these atoms will be in solid state, so they'll be sticking on this N metal rod. And in the end, because you are releasing atoms of N that are sticking here, each atom has some mass, so that mass that is going to bring it with is going to lead to this metal N actually increasing in mass. And K, remember, K was the one that was releasing electrons. As a result of releasing electrons, K converts to ions and it drops into this solution. And when they drop into the solution, where the electrons have been cut on this K rod, is is going to, or not going to be replaced, and in that case K is going to reduce in mass. So basically what we are saying is, at the end of the experiment we will find that K is having less mass and N will be having more mass, and in that case we are saying K reduces in mass and N is going to increase in mass. Reason, you know it. Good. Now why we are saying this electron is going to go this direction and not go in this direction is because we are looking at the electrode potentials here. Which one is more likely to pull electrons? For this case, these are more electropositive, likely to pull electrons. It's likely to pull electrons to itself. So N is more likely to pull electrons because for this case here it is having a higher electrode potential there, and K is having a smaller electrode potential, and in that case K is the one that is going to be losing electrons there. So this is acting like a magnet. The moment you connect these two cells together using a copper wire, then in between here you are going to use just a piece of paper. That piece of paper will be dipped in potassium nitrate, and it is going to act like a negative terminal. This is a negative terminal here, and this is a positive terminal that is carrying the electrons here, and this is just supposed to be completing the circuit. Remember, a circuit must have two two terminals, the positive and the other one, the other negative terminal. So just completing the circuit, and also ensuring that in case there is an unbalance of ions, it balances the ions on the left and the right of this cell here. So remember, the right hand side is where you are having the oxidation according to this formula of mine. There is where you will be having the losing of electrons there. Then on the right hand side we are having the reduction. The right, this R represents our right, having a reduction happening, there, and this is a gaining of electrons. So this is reduction, this is oxidation, losing of electrons, and the electron is being lost here. It is being pulled by this ion here, and this ion is going to gain the electron and to result into formation of sodium, an N ion solid, and this is we are going to form a metal ion there. So, yeah, this one, why do we need to learn this is because sometimes you find that you want to purify a metal, like for example this one here is an impure metal containing some impurities here. So when you use electricity, then in this case you will use two metals of the same. You will use an impure metal placed here, and the pure metal will be placed at the cathode. So the impure metal will be dissolving the ions of the metal in this solution here, and those ions are going to form the solution, and this side the electrodes come and deposit the ions on this side of the metal.